My name is Kedi Peter Paul, second year student at Murray University. I'm filing a bachelor's degree in software engineering. Can computers think? Could we have a computer that is able to think? So to answer this question, I'm going to use my an AI for agricultural resource planning and farm management. And I'm going to give it in 2 points of view ways, the philosophical part of it and the practical part of it. So agricultural resource planning AI, this is a tool that is going to help you to guidance, basically farmers and agriculture. You can predict the investment you need, the resources you need, and the possible yields you can, so you can get profit. And how you can sell it to get profit. We've had these stories that someone says, in poultry there is money. Yes, there is money. But they don't give you everything that you actually need. Know what you need for you to get that money out of poultry. Somebody doesn't tell you there's money. And in your head you may think, buy feeds, chicken there, and then you have money. But they forgot to break it down for you. There are ratios for the feed. So this AI is gonna do all that for you. So can computers think? If we really want to know what computers think, according to my understanding, first know what thinking is. This is the brain functioning, but it has awareness. You're cautious. You have emotions. Understand what's happening. Then how it works also with neural cells from the brain. So that's thinking. Now, can machines think? Or can a computer think? Computers just follow a set of rules. They learn the data that have been given, memorize, stimulate, and mimic human intelligence. Some philosophers did their studies and tests. So, but before we dig in, we really want to know what this is. So, there's weak and strong AI. Weak AI is basically synthetic, just follows a pattern, the syntax of something, it gives an output. But it carries in some intelligence, like the linguistic intelligence. In this AI, it can do the natural intelligence, because linguistic, if you give it wrong English, it's gonna correct it for you, as it gives you a report of what you want, right? Naturalistic intelligence, we're talking about the nature. This is agriculture, we're following nature. So it's basically you ask a question, I follow my rule. So you're basically talking about semantic understanding. That is completely almost a human. But so the consciousness and vision. Let's see if we could really have strong AI. So the training to really prove if computing. So this is how we had it in mind. You have two human beings and a computer. So you put one human being in a separate room from the computer. It's called also the imitation test. So you ask questions and have conversations, and then the person who is asking questions should differ which one is the machine and which one is human. So to dig into that, if the computer manages, if you fail to distinguish which one is a computer and the computer manages to prove to it's human, then it's a proof that it can actually mimic human intelligence. So here for validation in the project case study, you have the farmer, and in one room you have the agriculture expert, and the other room the AI. So you have to ask agriculture-based questions and see if you fail to distinguish, then wow, yeah, it can do your work, it's worth the work, but we're not really sure if it is thinking through. So Chinese room argument came in by John Searle, and he was not satisfied because, so his point of view, he was like, he created the computer. We all know a computer has just processes information, and then gives you feedback. So you have someone in the room who doesn't know Chinese, and then someone outside who knows Chinese. But the one inside the room has a guide or has the rules of Chinese symbols, how to manipulate them. So if someone outside sends a Chinese statement, and then inside he manipulates them, the symbol, and gives you a response. So take it like in this case study, you have the AI is the person inside, right? You give it, you ask it a question, and it gives you, like, you have initial capital of 2 million, you want to do poultry. So it breaks it down for you, the draft of the plan, but does it really understand the 2 million or the chicken? So does the computer really understand the Chinese? The person inside the room can't understand the Chinese, but is giving an answer. So that's not really thinking. So for some point of view, no happening. And then from the practical point of view, yeah, and some understanding to go and pick in. If I give you a book, right, and I tell you to give me something, let me say the introduction. You need an understanding to go get it and give it to me. So really, that's some kind of point of understanding. So to go to science, we have a computer that can think. It's basically saying we want strong AI in simple terms, because strong AI is like a human being, right? So the possibility, I would say, can be there, but it's kind of minimum with these limits, right? Because you need neural sets of a brain that actually computers don't have. So for the first limit, I would say the frame of problem by Dennett. Computers follow a logical pattern. They don't have common sense or relevance to what's happening. But if you ask it a question, even it can put in irrelevant information, unless you tell it to eliminate it, right? So it didn't have that common sense. Like, let me give an example. You're bored and then you decide to go and play video games. You thought about it and you went and played video games, right? That is thinking. You're hungry, you think, and then you go and get what you want to eat. So in the case study, imagine you have unpredictable occasions, like you're not sure. AI is not going to tell your chickens are going to fall sick, but who knows, they may fall sick. So now you ask AI that fall sick, there's this and this. Is it able to reason it out? Imagine it's a new disease. With an agriculture expert, he's going to come and advise you through, see through. But if you give it to a computer, it may be confused to have the data sets related to that. Nothing may be the limits of formalization. Some things are just for human. Like you can't put them in formal systems. Like not the point of understanding, intuition. You can't just put it into a computer. So without that being done, computers really won't have the basic of thinking. And that brings us next to Cordell's theory of incompleteness. Carl Cordell had it like some things that we all know, but does the computer really have proof? Can it really be proven to a computer? Let's say 1 plus 2 is 3. We all know 1 plus 2 is 3. But now, how are you really going to prove it to a computer that 1 plus 2 is 3? The way you tell a 5-year-old and really understand that next time when you get 1 orange and you get 2 oranges to give 3. So that's simply that computers don't really actually think. So the thinking they should be fast complete. So superhuman intelligence, like you have a lot of information, right? So you're well versed about something. You'll be sharp, you'll be fast at doing it because you know it. So is it really thinking computers because they may be a bit faster than us. Manipulation, it will be faster to do it, but is it really understanding, or is it just fast because it has a lot of data related to it? So with that also not being still figured out, computers don't really think. The possibility of them thinking has limits first solved. But in conclusion, it's a swift, incredible progress that I can say about computers are really improving, but they're just not complete. So if they find the solutions to the limitations and they become complete, then we have a computer that will think. But before that, giving an example, you've seen, I have a friend. I know him from childhood, but wouldn't really know what it means to be him. So, like he's called, you don't know what it means to be him, but you know everything about him. So that's how computers are. They would really know almost everything about humans, but they really don't know what it means to be human. So, to just prove their like the quality of it is legit, the decision is good, but they need human collaboration and human judgment for them to get the best result or for them to really work. So without that said, the possibility of computers really thinking is still kind of minimal, but who knows? But for now, it's not really sure that we will have a possibility that